Good morning, my dear friends. See now we shall see the second loss. Second loss is called loss of pressure due to anchorage take up and slipping of friction wedges. So what exactly this is, we'll try to see now. See now, whenever you instance now you pre-stress, say assume that this itself is your bar, okay, and then you are going to stress it. Am I right now? You are going to stress it and you are going to anchor it at the end. Okay. Say now, in the sense you already seen the Fresnel system and Magnell Batten system, different systems of pre-stressing we have seen. Okay. So now everywhere you have got some wedges. Okay. Wedges will be driven in when the pre-stressing operations are over. Am I right, sir? No? In the sense, as soon as you pull the wire, when you when you pull the wire like this, okay, when you pull the wire like this, okay, now afterwards what you are going to do is, now you are going to drive the wedges inside, or in case of Fresnel system, male cone is driven inside the female cone. Am I right, sir? Now, so now at that time it is in sense now the cable is tightly held. Okay, so now what happens is, now whenever you are driving the friction wedges or the male cone inside, okay, it may slip. When it slips, okay, now say for example this wire has been now stretched to this extent. When the friction wedges slip, okay, this wire also will slip, in a sense it loses its length like this. Earlier it was stretched to, say now, uh, say it is totally, it is stretched by 10 centimeters, say now. Okay, when the friction wedges deform, okay, at that time instead of 10 centimeter, this wire may become 9 centimeter. In a sense, 1 centimeter slip will occur. When slip will occur, when this cable tries to come to its original position, naturally you will see that it loses its pre-stress. Am I right now? Say for example, now I am stretching it now. I have stretched it to this much extent. Okay. Now say take for example in this rubber, 1000 kilonewton per mm square, excuse me, 1000 Newton per mm square stress is there now. I have stretched it fully now. Now, when it loses its length, say for example, now I will loosen it. I will lose until this. Now, do you think that the stress is now 1000 Newton per m square? No, it is not 1000 Newton per m square. It is less. Okay. So now, when it loses its length, okay, I say that the loss of pre-stress will occur. The loss of pre-stress will occur. Is it or not now? So loss of pre-stress will occur in the cable because of the, okay, slipping of the friction wedges, or anchorages may deform. Okay. So now different systems like Fresnel systems and Magnell Batten systems, they have got different deformations, etc., etc. It all depends upon how much pre-stressing you are going to apply. But anyway, if at all you want to calculate the loss of pre-stress due to this anchorage take up, or the slipping of friction wedges, okay, loss of pre-stress delta Fs is given by delta A by L into Es, where Es is, Baba, it is the Young's modulus of steel or the cable, Young's modulus of cable. See now here delta A by L is your original length of your cable. In a sense, it is the span of the beam, say now. Okay, span of the beam or original length of your cable, L. Delta A is how much slip it has occurred, how much it has lost its length. Okay, sir. Now delta A is that. So now delta A by L means it is the change in the length divided by the original length. Am I right now? Delta A is change in the length divided by original length. But this ratio will give me the strain. Am I right now? Strain into Young's modulus of steel. Okay. Strain into Young's modulus of steel will give me the stress. This entire thing will now become stress because it is a Hooke's law. Stress by strain is Young's modulus. So now delta A by L is the strain. Strain into Es, Young's modulus of steel, will give me the stress. So this itself we call it as the loss of pre-stress due to anchorage take-up or due to slipping of the friction wedges. So by this simple equation we can calculate the loss. Okay sir, now so now usually ES is taken as 2.1 into 10 to the power of 5 Newton per mm square for all the steels. Okay, so now based upon this, so now you can easily see here now, when the length of the cable is more, when the length of the cable is more, the loss is less.